So students, by the continuation of the ray optics topics, now we are going to discuss reflection of light and the concept of mirrors and related informations. The first one is what we are going to discuss, what is meant by reflection, or simply you can say what is reflection. Yes children, yes, a very simple understanding. You just see that this is some reflecting surface which is generally represented like this, a plane reflecting surface. For example, any reflecting surface is generally treated or called it as to be a mirror. Yes, okay, that we will discuss. You just consider a reflecting surface. And so yes, this is the incident ray that and all we discussed in the previous video, and this one will be the normal drawn at the point of incident, and this is what children? Yes, reflected ray. So this is the incident ray, this is the incident ray, and this is what children? Reflected ray. Okay, yes. What is meant by the phenomenon of reflection means, whenever light is incident and coming back after the meeting the reflecting surface, the ray is coming back to the same medium as where the incident ray travels. Such type of phenomenon is called what children? Reflection of light. Or in simple manner we can say that bouncing back of light in the same medium. Bouncing back of light after meeting the reflecting surface in the same medium is called what children? Yes, that phenomenon is called what children? Reflection. Okay children, yes, that is the very basic one. And the second one what we are going to discuss is this reflection phenomenon or actually we are going to discuss what is the difference between ray optics and wave optics. This ray optics, we are considering a very basic property of the light that is called rectilinear or straight line propagation of the light wave. Yes. So on that basic assumption only we are discussing all the phenomena in the ray optics. But in wave optics, the light is not considered to be a straight line, it is considered to be a wave. Yes, that we will consider later. But here all the ray optics phenomena is based on our assumption that the light is, by considering the not assumption that is the property of the light, rectilinear propagation or straight line propagation of the light rays. So that is the basic thing. So it's falling on the reflecting surface, incident ray, and it's bounced back to the same medium. Suppose if it is air medium, this ray also should come to the air medium only. So such type of phenomenon is called what children? Reflection of light, and this angle is called angle of incident. This angle is called angle of reflection. Angle of reflection. And the normal reflecting surface, reflecting what children? Reflecting surface, that and all you know that. And this angle is called generally angle of glancing angle. It's not only here, if you are measuring here also, the angle between ray and the reflecting surface is generally called a glancing angle children. Yes, you please keep that one in mind. Yes. And next one is what we are going to say is the laws of reflection. Laws of what children? Is a reflection of light. Yes. Just see that the first one what the law says that is the first one is what children? Angle of incident should be equal to angle of reflection. Angle of incident should be equal to angle of reflection. Here we are just giving the statement alone. The proof of this concept will be discussed in geometrical manner as well as in another way. But in a Cbse point of view, that proof is not necessary here, but it will be discussed in wave optics topic children. Okay. So the first law says that, what children? The first law says, law 1 or first law, we can say that first law. The first law says what children? The angle of incident equal to angle of reflection. This is the first law for the, so we can consider that as to be first law for the angle of reflection. And the second law, what it says? The angle, the incident ray, the reflected ray and the normal all are lying in a same plane. So the incident ray, reflected ray and the normal drawn at the point of contact. This is called point of contact or point of incidence. Point of incidence. Point of what children? Incident. So incident ray, reflected ray and the normal all are lying in the same plane. All are lies in the same plane. That means here it is lying on the plane of the board, or we can assume like that. So therefore lies in the same plane. What children? Same plane. And this is, I can say, or we can say that the second law for reflection of light. Second law for what children? Reflection of light. Okay. And one more information I can given that here, you just see is this is the reflecting surface and incident ray is normal, and this will be reflected ray. Okay. So this is called incident angle, reflection angle, and this is called a glancing angle. You just, if there is no reflecting surface, this light should travel in a straight line. That we said a rectilinear property. But because of the reflecting surface, it gets deviates from the straight line path. And now this angle, the angle between its original path and the reflected ray, this angle is called what children? Deviation angle, or we can simply say that angle of deviation. Angle of what children? Deviation. That concepts and all not asked in a Cbse point of view, but we must know what is the term. How much the light ray is deviated from its original or actual path because of the reflecting surface is called what children? Angle of deviation. That is what children? Angle of deviation. And as we said earlier, that what is normal incident? What is normal incidence? That we already discussed in the previous video. Normal incidence means, I can very shortly I can say that, since we are already discussed there. So if the incident ray is perpendicular to the surface of reflection, so this is the reflecting surface. If the incident ray is perpendicular to that, then it is parallel to the normal. Therefore we can say that angle of incident equal to 0. By the law of reflection, angle of incident equal to angle of reflection. Therefore angle R also what children? 0. But it is what children? But the direction of the light is retraces, or what is that? Its direction gets reversed or opposite. That is called retracing. That is called what children? Normal. And one more thing I can say, that since we are going to discuss the types of mirror, very general, in a very general point of view, I can say that the mirror means any reflecting surface. It need not to be a glass one and coated by silver or any chemical substances. That is not a mirror. Any polished surface which can reflect the light rays when it's fall on it on the surface, that is called a mirror. Okay. But in general, in normal days, mirror means we are considering the glass surface only. But in general, any reflecting surface. So now next what we are going to discuss is what is mirror and the related basic concepts. So the next concept is what children? Is mirrors. In general, I can say that, in very general manner, I can say that mirror means what children? Any reflecting surface. Any reflecting surface is generally called what children? Mirrors. That is called a mirror. Okay. And here the mirrors, there are two types of mirror. I can say that mirror types. What are the mirror types or means? You just see that one is called plane surface. That is plane mirrors, like a normal mirror what we are used for the a salon shop or in a beautician, like that. And another one is curved mirror. What children? Curved mirror. In curved mirror can also is divided as two category. One is called what children? Is spherical, and another one is what children? Is hyperbolic. Hyperbolic. Okay. So spherical mirror, that and all you know that is vehicle and they are using convex mirror. And in dental, that and all, that basics informations you are already studied in 10th standard. So they are used in a dental, they are concave mirrors. Such type of mirrors, spherical mirrors, are generally called this category, belongs to curved mirror category. And another one is hyperbolic. So here spherical mirror also divided as two type. One is called what children? Is a convex mirror, and another one is called children concave mirror. You may study that. A spoon what you are using, so the side which will be it will be curved like this, and this surface is curved as inward. It should be like this. This is called a concave, and this outer surface is called what, children? Convex. Okay, I am not going that much very basic level since you are already studied in 10th standard. So convex mirror means it will be as for example denoted like this. So the front one is a reflecting surface, and this is the a light cannot passing through the shaded portion. Okay, the concave mirror means it should be like this. The reflecting surface will be curved inward, but here the reflecting surface is curved outward. That is called a convex mirror, and this one is what's done? Concave mirror. Okay, the plane mirror is very simple. As we said here, this is the plane mirror. It may be in the horizontal position or in vertical position. You can consider in any manner. Okay, and next one is hyperbolic mirrors. There is some problem with the image formed by the spherical mirror that we will discuss in successive topics. So that one is hyperbolic mirror. That one is what's the hyperbolic mirror. So yes, it will be placed like this. Such type of mirrors are called hyperbolic mirror. What is the purpose of hyperbolic mirrors? To avoid the distortion in the image formed by the spherical mirrors. What is that? That will be discussed in the next classes, successive classes. So these are the information about what is mirror and the types of mirror, children. Yes. The another one what we are going to discuss here is the basic terminology used in mirrors. Basic terminology used in mirror. Before that, I can say that rules for image formation. Rules for what, children? Image formation. So this is very important for our as a subject point of view. So these are the basic things we must keep in mind to draw the any ray diagrams, because the diagrams are very important in ray optics. The rules for image formation. For your better understanding purpose, I can take as a concave mirror. Using that I can explain this rules. Okay. It's common for any kind of reflecting surface. It need not to be as concave or convex or hyperbolic or plane. Whether it is regular or irregular, it doesn't matter. That if a reflection takes place, there you can use these rules, laws of reflection, as well as here also the rules what we are going to state that can be used. The first one is, for example, I am taking the for the better understanding, I am explaining these rules based on this concave mirror. Yes, that is suitable for all type of reflecting surfaces. Now please see that if this is the concave mirror. You just see that a concave mirror, and a line passing through the this is the mirror. Its center is called the pole. Center is called what, children? Pole of the mirror. Yes, the geometric center, middle part of that. A imaginary line passing through that is called a principal axis. This is called a pole. This is called what, children? Pole P. Yes, and the line is called what, children? Principal axis. Principal axis. Okay, that imaginary line is called what, children? Principal axis. Okay, now please see that. Now, if there is a point that is called F, that is called a principal focus. What is that? That and all will be, I will explain as a separate a subdivision. But here for rules formation, I am just telling what is this F. F is called a principal focus, and there is another point that is called C, that is called center of curvature. I will explain these definitions, but for rules, to state the rules, you just follow this. So center of curvature, C for center of curvature. Okay, children. Now please see that the first rule says that if the incident ray is parallel to the principal axis, if the incident ray is what, children? Parallel to the principal axis, then after reflection the light ray should passing through the principal focus. The light ray should passes through the what, children? Principal focus. This is the first rule. So the second one is, you just consider the rule 2. The same is a similar concave mirror, and this is P, pole of the mirror, F, and this has to be C. These are the points. Okay. Now the just reverse of this. If the light ray is passing through principal focus, if the light ray is what, children? Passing through the principal focus, then after reflection what will happen, children? the ray gets reflected parallel to the principal axis. Parallel to the what children? Principal axis. Just reverse of this rule. Okay. The third one is that is very important thing. How to draw the normal, because as we said here, all the angles are measured with respect to normal. For plane surface, it's very simple. At the point of incident, you draw the normal. It's very simple manner. But in the case of what children? Yes, in the case of spherical surface, how to draw the normal means, we know that in the mathematics we will study that yes, the tangent is always perpendicular to the the radius. Tangent is always perpendicular to that what children? Radius. So in case of any spherical surface, from where we have to draw the normal means from the center of curvature. A line drawn from the or which is passing through the center of curvature of the mirror is taken as to be normal if the incident rays are falling like this. Okay children, yes. So this is the what a small thing you just keep in mind that. Okay. So in case of plane reflecting surfaces, it's very simple. You just draw a perpendicular line at the point of incidence. It's very simple. But in the case of a spherical reflecting surfaces or refracting surface, whatever may be that, you just draw a line. Just draw a line from the point of contact or from the point of incident through the what children? Center of curvature of the curved surface or spherical surface, reflecting surface. Now this line will act as a what children? As normal line. This line will act as a what children? Normal line. You please keep in mind this one, how to draw the normal in case of as a spherical surface. So now with the third rule is just consider the concave mirror. Yes, and as we said, this is P, this is F, this is C, like that. What the third rule says, if the light ray is passing through a center of curvature, if the light ray is passing through what children? Center of curvature, after reflection, it retraces its path. After reflection, what children? It retraces its path. It's very similar to our normal incident, what we said here. Because as we said here, the line, imaginary line passing through the center of curvature and the point of incident is generally called what children? Normal for the curved surface. Just see this idea, apply this idea here. So this is the center of curvature and the point of incident. This line is what children? Act as a normal. Now the incident ray is lying or parallel or passing through the normal itself. That is nothing but normal incident. That is nothing but what children? Normal incident. Therefore, in this case what children? I equal to 0 as well as R also will be 0. Therefore, the incident ray will retraces its path. That is the third rule. So whenever light ray is passing through C or towards C, then after reflection or refraction may gets what children? Retraces its path. Yes, here in case of this, so whenever light is passing through the center of curvature, it will retraces its path. Retraces its what children? Path. Okay, the fourth rule. The fourth one is, you just consider all these first three rules are valid or same for or applicable for lenses also. So there I will very briefly explain this since you are watching this video. So all this rule, the first rule. What is the first rule children? If the incident ray is parallel to the principal axis, after reflection it is passing through principal focus. If the incident ray is second rule, incident ray is passing through the principal focus, after reflection it is parallel to the principal axis. Third rule is if the incident ray is passing through the what children? Center of curvature, it will be reflected back. All these three with a slight modification can applicable for lenses also, but this is the fourth rule is applicable only for mirrors. That is, you just see that this is a pole and the principal axis. Let us consider that this is F and this will be C, center of curvature, principal focus. Now please see that children, this is the incident ray. Now for this point of incident, this principal axis itself normal. Principal axis itself what children? Normal. Therefore, let us consider this is the angle of incident I. So according to our yes, laws of reflection, angle of incidence should be equal to what, children? Angle of reflection with respect to this normal. In this case, the principal axis itself will act as a normal. Therefore, this is the yes, the last or fourth rule is where I is equal to R. Where I is equal to what, children? R. If the incident ray makes an angle, yes, makes an angle with the principal axis, after reflection, the reflected ray also produce the same angle. That is angle of incident equal to what, children? Angle of reflection based on the laws of reflection. These are the very important 4 rules we must know to draw any kind of ray diagram, because most of the MCQ problem or Cbse related problems are mainly related to ray diagrams. So there we must know how to draw the ray diagrams, because in some cases in question they are given complete the ray diagram or a small part of the diagram is given. Further we have to draw the ray diagram. For that purpose, yes, you must know these 4 rules, children. Okay, now please see that. Okay sir, 4 rules are there. Then how many rules we must apply to get the yes, image formation? So for that, yes, any 2 rules are enough. Any 2 rules, that is our choice. Which one is comfortable to draw the ray diagram, that any 2 rules can be used. So any 2 rules are sufficient to get the image formation. For example, I can yes, draw the ray diagram. Yes, yes, you just see that, children. Yes, now we consider a concave mirror. Yes, we are going to yes, discuss. Now please see that this is pole of the mirror, principal axis, and this is the principal focus. This is called the center of curvature. For example, if I am keeping the object between, this is the object placed between C and F. It's generally denoted as, for example, AB. AB is a real object. As we said in the previous video, the most of the cases are in very general cases. We are telling that objects are placed left side of the mirror or lens system, and any height above the principal axis is called positive, downward will be negative, and along the incident ray direction is positive horizontal distances, and opposite to that will be negative, and all the distance are measured from the what, children? Is a polar or optic center of the lens or pole of the mirror. Such type of things we are already discussed. That also should be remembered here. So I am going to apply the first rule. That is our wish. Any rule you can use it. Therefore, what the first rule said, children? Whenever the incident ray is parallel to the principal axis, after reflection it is passing through the principal focus. First rule. Okay. Any rule, any 2 rules we can use it. That is our choice. As for example, I am going to yes, consider the another one. Which one is comfortable for us? We can use it. That, for example, if a light ray passing through the yes, principal focus, if the light ray is passing through the principal focus, after reflection, what will happen, children? They will yes, reflected back to yes, parallel to the principal axis. So after this 2 rules I applied, that is our choice and convenient one, we can use it. But after applying the 2 rules, then the point of intersection of these reflected rays, the point of this center of curvature, AB is the as a real object height, AB. So this after the applied these 2 rules, any 2 rules, where these 2 rays are meets or intersect, that is the position of the image. Okay, children. So it is intersects in downward direction. So therefore I can draw in outward direction, the downward direction, that is a B dash and what, children? A dash. So yes, because this is the why it is A dash, because this light ray is coming from A, that's why it is A dash, and this light ray is same as to be like as we said the normal incidence. This will be go and this will be coming back. Yes, so therefore this is image. So in this manner, so this is object, real object, and this is what, children? Inverted image. We know that the real images are inverted, so these are real image. Okay, children. As this is the way how to apply yes, the what is that, children? As a rules for image formation for any reflecting surfaces or refracting surfaces. Yes, children. And the another one more is a thing will be there, that is the basic terminology used in yes, spherical mirror. What is yes, principal focus, focal length, and the center of curvature and the radius of curvature, that and all will be discussed. Please kindly note down this, children.